In section 4.6b, we're going to be graphing tangent and cotangent functions. So, using our unit circle, we're going to complete this chart, and when we do that, we're going to remember that tangent of x, when we're on our unit circle, is y over x. We're actually going to start at 0, okay, and when we are at 0 degrees, or 0 radians, my y value is 0, and my x value is 1. So my tangent, 0 divided by 1, is 0. That happens again at pi, because although my x value is negative 1, my y value is still 0, so that fraction still comes out to be 0. All right, now let's look at pi over 2 and 3 pi over 2. And then negative pi over 2 is the same thing as 3 pi over 2. They're coterminal angles. So at pi over 2, we're a quarter of the way around the unit circle. My y value is 1, but my x value is 0. So when I take 1 divided by 0, well, I can't divide by 0, so that is undefined. The same thing happens at 3 pi over 2, which is the same thing as negative pi over 2, because again, my x value is 0. All right, so now we have to look at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 would be the same thing as negative pi over 4. So each of those, if you remember from the unit circle, those are my 45-degree angles. So the two sides, x and y, have the same ratio. So they are 1 and 1. So dividing by those, in quadrant 1, both x and y are positive, so is tangent. And in quadrant 3, which is 5 pi over 4, they're both negative, but a negative divided by a negative is again a positive. In quadrants 2 and 4, I have a negative and a positive, so my tangent is negative 1. So what does that look like on a graph? Well, just like we saw with secant and cosecant, if my graph has an undefined point, I'm going to get a vertical asymptote. So here, for tangent, those now happen at negative pi over 2, positive pi over 2, 3 pi over 2, and so now we can tell that they are happening every pi radians. So I'd have one at negative 3 pi over 2 as well. Okay? As you can see here, this is no longer 2 pi between vertical asymptotes. So my new period for tangent, and turns out for cotangent as well, is just pi. Okay, let's plot some points. So when x equals 0, f of x is 0. At pi over 4, it's positive 1. And at negative pi over 4, it is negative 1. So although this looks like it may form a line, it doesn't, okay? So it looks actually kind of like a cubic function, except it's going to be constrained by these vertical asymptotes. And so again, this repeats, all right, as we go through each of our periods. Okay, so do your best to not make that linear. You want to make it look like a cubic where it changes concave up and concave down at that inflection point. Next, we're going to look at cotangent of x, which is 1 over the tangent of x, or now x over y. So the funny thing is, at our 45-degree angles, we haven't changed. So at pi over 4, it's still positive 1. At 5 pi over 4, it's still positive 1. And at 3 pi over 4 and negative pi over 4, my cotangent is also negative 1. But what has changed is that now my zeros and my undefined points are going to switch. So at 0, my y value is now 0. And so this is undefined. And then again at pi, I have an undefined point. And then my zeros happen at pi over 2, 3 at pi over 2, and then all their coterminal angles. So now, I'm still going to draw my vertical asymptotes first. And so now they happen starting at the y-axis. So instead of my graph being centered there, it's going to start there. And again, they happen every pi radians in both directions. So there are my vertical asymptotes. And now I'm going to plot my zeros. And these happen halfway between my asymptotes. So really, once you've got those, you can just go halfway. And then I need to figure out, all right, whether I go up or down from there. So every pi over 4, I have a key point that I'm going to plot. So at pi over 4, it's still a positive 1. And at 3 pi over 4, it's still a negative 1. Okay, so again, it looks like they could form a line, but we've got asymptotes, so we know this is going to actually be a curve. Okay, and then that repeats again within each period. You'll notice that unlike sine and cosine, which had a limited range of y values, these go to infinity, both positive and negative. So when we talk about amplitude, when we start doing transformations, we're not going to be looking at the maximums and minimums. We're going to be looking at these points that were at a y value of 1 and negative 1, and we'll stretch or compress those. So let's look at that. So now we're going to look at our transformations for tangent and cotangent curves. Since in 4.5 we looked at all of our different variations on our trig function graphs, we're going to actually jump right in and do all of them right here. So you'll notice that these basic equations look very similar to what we've seen for sine, cosine, cosecant, and secant. All right, so A is still my coefficient out front, and now, while before it was an amplitude, it's just a vertical stretch or compression. So you could think of this as shrinking vertically. All right. The period for tangent and cotangent starts out as pi, not 2 pi, but it's still divided by b. C is still a phase shift. And D is still a vertical shift. Okay, a vertical translation. So, since these don't have amplitude, again, it's not going to be affecting the maximums and minimums. It's going to be affecting how far those second points are that we plot. All right, so let's look at that. So this first one, example 3, the only transformation it has is a vertical stretch, and that's by a factor of 1/2. There's no reflection. The period hasn't been affected, so it's still pi because we're on cotangent. Okay? There is no phase shift, and there is no vertical displacement. So for cotangent, all right, my first asymptote I want to draw is at x equals 0, unless I've got a phase shift. All right, but in this case we don't. And then my period, I'm going to look at that. That's pi, so I'm just going to go every pi radians to the left and right and draw my vertical asymptotes. Okay, I have no vertical displacement, so my zeros are still going to be at 0. So I can put those in. Okay, and then cotangent is going to be a graph that is decreasing or undefined over its entire domain. So that if you think of tangent as increasing and cotangent as decreasing, that may help. So what that means is before I would have had points here and here at pi over 4 and 3 pi over 4, but I have a factor of 1/2. So once I take the cotangent of x, I have to then multiply by 1/2, which means that these points are actually now here. All right, so when I draw my curves, they're a little bit flatter when I'm closer to that x-axis. Okay, and so again, this would repeat every period like so. In our next example, we have a reflection vertically, and we have a b value, so my period is going to be pi divided by, in this case, pi, or 1. There is no vertical stretch or shrink, there is no phase shift, and there's no vertical displacement. So this is tangent, so my asymptotes are going to be centered around x equals 0. And in this case, my period is 1, so I'm going to go half of that to the right, so at a 0.5, and I'm going to draw a vertical asymptote. And I'm going to go to the left of x equals 0, and I'm going to draw my asymptote. At this point, if I had a phase shift, I would go ahead and shift, all right? But I don't, so I'm going to leave them there. And then every difference of 1 on the x-axis, I'm going to draw an asymptote. Okay. Again, this is tangent, so there's no vertical displacement, so my zeros are still at 0. But instead of tangent being an increasing function, where my points would be at 1 when x is positive there between 0 and 0.5, instead, now it's going to be a reflection of that, and then over here it's going to be above the x-axis. And so now, and then we continue that pattern on within each period in between our vertical asymptotes. In our next example, we have a vertical stretch by a factor of 1/2. There's no reflection, no phase shifts, or vertical displacement, so no translations, but our period has been affected, and it's pi divided by b, which is 2. So our period is every pi over 2. This is cotangent, so unless I have a phase shift, that first vertical asymptote is at x equals 0, and then every pi over 2, I'm going to have a vertical asymptote. Okay? Because there's no vertical displacement, my zeros still happen at y equals 0, and they still happen halfway between every vertical asymptote. And now, because I've shrunk my period by half, all right, I'm going to be looking at those other points that I'm going to use to sketch my curve. I'm going to be looking halfway between my vertical asymptotes and my 0. So this is cotangent, so this is going to be a decreasing function the whole time. So at pi over 8, so that is going to be here on the x-axis. All right, normally that's where I would have a y value of 1, but because I have a vertical shrink, or a vertical stretch with a factor of 1/2, all right, it now goes here, okay, and then it's symmetric there. And so I have a little bit tighter curve that I have to make. All right, and I'm only going to do a few of these ones. All right. And again, this would repeat every period over however much you have, but you may not have to draw every single one. On the test, we'll tell you how many to draw. In example 6, we have a vertical stretch by a factor of 2. We have no reflection and we have no phase shift. All right, our period is still just pi, but now we have a vertical displacement. Okay, so this is tangent, so so it's going to be centered around the y-axis. My period is pi, so I'm going to go half of that to the right of the y-axis and half of that to the left, okay? And then I'm going to do that on intervals of every pi to the left and right, continuing on. Okay, so now I have my vertical asymptotes. There's no phase shift, so they stay there. And neither a vertical stretch or a vertical displacement will affect where those asymptotes go. Now, the vertical displacement is going to change where my zeros go. So what would have started out at the origin is now shifted up, in this case, by 1. And that's going to happen in every interval, all right? They're still going to happen halfway between each asymptote. Okay, now we also have a vertical stretch. So at pi over 4, okay, I initially would have had a value of 1, and then we had to stretch it, okay, and then we have to move that. Okay, so it's kind of like an amplitude in that I'm going from wherever my 0 is. I'm going to go up that number to get to my points that I'm going to use, and then I'll go down. So this is 2 above 1, and then on this side I'm going to go 2 below 1. And now I have all the points I need in order to draw my curve. And it's a little bit steeper, so you'll have to be a little more careful to make it not look linear. All right, and again, this will repeat within every set of vertical asymptotes. We're actually going to skip the next one at the top of the next page, so we're going to move on to example 7, which is graphing y equals the tangent of 2, x plus pi, and then minus 1. So here, we do have a phase shift, and it's pi to the left, because it was minus c, so this is really a negative pi. All right, there's no reflection. The period is now pi over 2. I do have a vertical displacement, but there's no vertical stretch or shrink, so there's none there. Okay, so this is tangent, so I'm going to be centered around the y-axis instead of starting there like cotangent would be. All right, so my total period is pi over 2, meaning that I need to go to the right by half of that, which is pi over 4, and then to the left of the y-axis by that amount, which is negative pi over 4. All right, and then again, every pi over 2, I'm going to have a vertical asymptote. Okay. So we'll think next about where our zeros go. And we know they would be centered between asymptotes. So normally I'd have one at the origin. But I have a vertical displacement of negative 1. Okay, so it now happens 1 below the x-axis in every period. So before I start drawing the curve, I have one more thing I have to do. I have to do a phase shift. So the phase shift would be pi to the left. So if I took that dot and I move it pi to the left, in this case, it ends up still in the middle of a set of vertical asymptotes. So I would have had a 0 there anyway. In this case, my phase shift hasn't done anything. But to show you how that would work, all right, so starting from my 0 that's been vertically translated down, okay, I'm now going to draw a point here and a point here. You'll notice that they are still a distance of 1 vertically from where my 0 was that's been shifted. All right, and tangent is an increasing function, all right, over its domain. So we're going to do that. Okay, so what initially was centered at the origin is now 2 to the left, but here's a little secret. If the phase shift is an integer multiple of the period, so if I can multiply that period by 2, 3, 4, or negative 2, 3, 4, etc., then actually the phase shift doesn't end up doing much of anything unless we ask you to draw the period that would have started at 0. Finally, we're going to look at writing an equation from the description of a function. So in example 8, we know that we're going to have a tangent function, and so this looks like this, okay, as my parent function. And so we can actually go ahead and write in our parent functions here, except this one's cotangent. All right, and now we're back to tangent here. And now we just have to go through the descriptions and identify what we have for transformations. So in example 8, we have 4 pi as a period, so that means that 4 pi equals pi divided by b. So when I multiply both sides by b, I get 4b pi equals pi. Divide both sides by pi, so that's 1. And then divide both sides by 4, and I get b equals 1/4. Okay? And my vertical shift is 3, so that is d. If one of these variables is not listed, then its default value is going to go in there. And so in that case, A's default value is 1, so we don't have to write it. And C's default value is 0. The default is no phase shift. Okay, so we're going to rewrite this. Now, so there's no A that I need to write in, but I do need to write in B. Okay, so in this case, I don't even really need the parentheses, right? All right, but then there's plus 3 at the end. All right, let's move on to example 9. So the period is 2 pi, so 2 pi equals pi over b, which means that b has to equal 1/2. Okay, there is a phase shift of negative pi over 4, so that is C. And remember, if I take minus a negative, that becomes positive, okay? So that's how I would get a positive value inside my parentheses. So here, my function is y equals the cotangent of 1/2 x plus pi over 4. And there is no d value, so I'm done. For example 10, I have period pi, which means b equals 1. Vertical stretch is 3, so that is A, because remember that's similar to my amplitude, okay, in sine and cosine. And then I have a phase shift to the right of pi over 2, so C equals positive pi over 2. Okay, so when I plug this in, A now equals 3. I don't have to write anything for B, but I do need my parentheses because C's inside there. And so it is x minus a positive pi over 2. There's no d, so I am done.